Hello guys. Now kindly confirm if you are able to hear me. Am I audible, guys? Hello. Okay, thank you. So we are going to start from where we had left yesterday. So we were working on list. Okay. So when we talk about uh, data structure or simply collections, there are basically four types of collections. One is the list. Two is your tuple. Three is your set. And four is your dictionary. Right. So these are the four ways in which you can basically combine and present the complete different data types in a group. Right. We call them collections or data structure. The first one is your list. Now, how do you create a list? List is simply created by or putting all the data types with separated by comma inside a square packet. Right. That is how you create a list. Okay. So you can have uh, element one. Let's call EL1, EL2, EL3, EL4, and so on, right? Where your EL is could be any data type. Right? So list is a collection of different kinds of data types. Okay. Okay. Let's create a list quickly. I'm going to name it as L1 equals to 1, 2.2, true. Hi. So these are the five data types that we have studied, right? And they are being collected together and kept inside a square packet, collected and separated by comma. Right, you can see that all these elements are separated by comma. Okay, now these are what we call elements, right? This is element 1, this is element 2, this is element 3, this is element 4, this is element 5. Okay, let's see what kind of if you find out the type of L1, it's going to give you a list. Okay. Now lists are the most powerful. It's the most powerful data structure that you have. It can be manipulated in any way that you want, right? And that is one of the biggest thing about lists. So wherever you are talking about, whenever you're talking about data manipulation, right? Then you're definitely going to involve lists in Python, right? Especially data analytics. You use a lot of lists. If you're not using libraries like pandas or NumPy, then you are using a lot of lists. In fact, even if you're using the libraries, you will be using lists a lot. Okay, so this is quite powerful and quite famous in that sense. So lists also support indexing. Okay, let's create two lists, guys. Okay, let's see a few other things. Let's have L2. First, we'll say this list is normal numbers. Okay, so you can add the list. That is basically your concatenation, right? That's something that you can do. Adding the list. You can have repetition, just like your string. Right. So list supports concatenation. It supports repetition. Okay. Concatenation, repetition. Apart from that, list is an index data structure. Okay. List is a index data structure. So list also supports indexing. Actually, indexing and reverse indexing is what is supported by list. Now, how does indexing work here? It's so easy to understand, right? How indexing might be working here in the same way that it worked in string, right? In string, every character that was falling under the double quotes was considered as an individual element, and we were able to fetch that element, right? Here also, we only talk about element, right? As in, what are the values separated by comma are basically your element, right? And they can be indexed. Okay, you can find out the length of list. That will give you better clarity about how many elements do you have in list. So length of L1 is 5. That means that it has 5 elements. So obviously it has all the 5 data types that we have studied, right? So you want to find out what is at the 0th position. Then you have at 0th position you have 1. What is at say 3rd position? That is a complex number, right? So again, your list supports indexing. Okay. The concept of indexing is same that we had in as we had in string. Now, in list also, your position does not change. Your position remains fixed. So, for example, if you have a list like this, let me copy this. Right. No matter what, how many times you print it, no matter what, how many times you call it, the position of the occurrence of these elements are not going to change. These are fixed. Why? Because Python has made them fixed. Right. That is how your Python basically work. Okay. So your index of the elements are not going to change. So it's going to follow the same pattern that we had in string, right? And what is that pattern? So you have keys and you have values. Okay, let me show you keys and value. So what is the value here? 1, 2.2, true, 5 plus 6, j, hi. Right, so these are the values. Okay, so they have the fixed, you can call that index or fixed position, which are represented by what? These are basically represented by starting from 0, 1, 2, 3, 4. Okay, so if you want to fetch the value, say 1, then you'll have to call via index 0. Right, so basically how are you going to call it? Call it L1 key, and it's going to fetch you value. Right, this is how basically your indexing work. Okay, so that is what it does. It supports indexing. So that means that, uh, see, whenever I say that it supports indexing, then it is by default that the position of the first element in a list or string or any data structure that we want to study is going to be 0 or fixed. Okay, that is one thing that you should always keep in mind. But do we have any document for these theories? Yes, you can find it on the uh, list and Python 3. Yeah, we have data structures, Python 3.7, documentation. Right, you can find all these things here. Okay, so any documentation that you're looking for, you can find on docs.python.org. Okay, you find everything here. Apart from that, I think that is the best source of learning for you all. No, I'm just going to come to this point on. Right. Now, regarding this, there is no documentation, but yeah, it works like this only. Okay, so apart from that, guys, see, you can do the indexing, you can do the reverse indexing. Okay, that means that I can access the last element using -1. Right, I can do that. I can access the last element using -1 and so on. Right, -2, that give me a complex number. -3, -4, -5, that will give me 1. 2, 2.2, and 1. Right, so it supports reverse indexing also. Now, one of the property of list, in fact, now comes the properties which are quite fascinating about the list, which makes it quite powerful. One is you can have multi-dimensional lists. Okay. Okay. Before moving to multi-dimensional lists, check slicing, guys. Okay. So again, list supports slicing. Say I want to slice out true and this. See, guys, the perspective or the concept of slicing remains the same. Only the perspective changes now. You're not dealing with a string. You're dealing with the elements. So instead of characters in a string, you have to substitute it with element, right? Okay. Now element are not characters. These are your data types. Okay. That is the only thing that you have to change. Now, for example, here, guys. Okay, I'm going to copy and paste this here. Okay. Now, the list that I've pasted, I want you to slice out these two values and print it. Slice out true and 5 plus 6j, guys, and print it. So we have done this yesterday on a string, right? Try it out on list. Let me know what you get doing it. Yes, Prashant. Uh,
Hi, Vedant.
do
Prashant.
you have any query?
Yeah. Actually,
Sure,
what I want to
please.
ask is, if you want to print a list in by using reverse indexing, then it's a complete in reverse manner. Then how to do it?
Sorry, you
I
want to
want to,
print the complete list in a reverse manner.
yes, by using reverse indexing. Then
Yes, we have done that actually. Try it out. The same method. We did that with the string, right? Whether we convert it into a reverse order. Right? That is a standard method you can use, standard formula.
okay.
Do you remember
So
that?
is there?
Sorry.
mm, Uh, can you repeat it again?
Yeah, sure. I'll show you.
Yeah.
Okay.
Yeah. Yeah.
Okay.
Thanks.
Okay. So first, let's see this. So a lot of you have tried this. Not a lot of you. I can say only two of you have tried this, Swati and Deep. Okay. So your indexing remains the same, right? You have L1, right? The element. This is what 1, 2, 3. Third element. So its index will be 3 minus 1, 2. Right. So I'll have to start taking element from 2, which is true. Right, true, and I wanted to take it till high. So it'll be index 2, index 3, index 4. So that will be index 4. Okay, true, comma 5 plus 6j. Try it out. Okay, try it out and let me know. Say, I'll explain you how it's working when we'll be working with, say, a particular function where you have to start, stop, and hop or jump by a certain value. At that time, I'll be able to explain you this properly. See, by writing minus 2, it is jumping from this to this, this to this. Writing minus 3 is going to jump from high to 2.2. Writing minus 4. So I'll have to explain you jump, right? That is something that I'll be able to explain you with uh, another perfect example, then we can translate it here, right? Just understand that if you want to reverse it, you simply use this double colon actually. It's not going to give you anything. Right? Yes, you can save it in new variable. It's up to you. Okay, this is what we use to reverse complete index list. Now the changes, guys, are these changes going to be saved here? That is one of the questions. So I've done all these tasks, but is it going to be saved on my list? No, because it does not take place on the list, as in it's not a permanent changes that we have made, right? Okay, understood, guys? Now, next concept, which is quite a lot used in list, is multi-dimensional list. is your list inside a list, right? Now I'm going to reduce. Okay, I'm going to clear this. Now, how does your multi-dimensional list looks like? Okay, I'm going to write it here so that you guys understand this. Let's say that it's L2, and uh, I want to create a list inside a list, right? So all the element are also lists. Okay, see this? So this is your bigger list. Inside that we have smaller lists, four smaller lists. Inside that, what I'm going to do is I'm going to create 1, comma 2, comma 3. Let's have the elements who itself are lists. Let's have them as um, a list of 3 elements. Okay, check this out. So this is my multi-dimensional list. Now guys, here in multi-dimensional list, see, the reason we call list such a powerful data structure is one of the reason is that you can access the elements within the list, and that too, again, you have another list inside it, right? Okay, so for example, okay, so you have this list. Now I want you to say print hello from here. How are you going to print it? Using indexing. Try it out. So I just want to see what is your approach on this. So understand this, guys, that your this is element one, like your element two. Yes, they exactly. This is basically element three, right? And if this is element, basically element three. Okay, so these are basically your element. Now try it out. Printing only hello with the help of slicing. Okay, try it out, guys. Okay, first of all, you understand that your hello is in the third element, right? So the third element will have index 3 minus 1, that is 2. You have, so you got the third element, which is again a list. Right? Now this is again a list, and this list, yes, Prashant, you can do like that also. So this is again a list. So indexing again is applicable on this list. Now the inner list that you have got, see, consider it as an individual entity now. Your L22 gave you a new list. Right, now forget about the previous list. You got this. Now inside it, which element is hello? 1, 2, 3. So it will have index 2. So now you already were able to fetch the list as this. What are you going to do? You're going to do L2, index of 2, index of 2. or element and index of 2. Okay, so this is how you work with multi-dimensional lists. Yes, you can do it like this also. Simple. You will assign it to a new variable, this L2, and then new variable is your list, and then you can perform the indexing of that new variable also, new list. See, there are several ways in which you can do this task. A lot of you have done that. So it's like L2, 2 minus 1. This one way. Okay. You have L2 minus 1, L2 minus 1. You can use a complete reverse indexing. They all mean the same. Why? Because they all are pointing toward the one element, only one element, which is hello. See this? If you have any doubt here, kindly ask me. So whenever you are learning, or whenever you are going for, say, you want to learn data analytics, you want to learn using Python, you want to learn machine learning AI using Python, you want to learn automating your tasks using Python, then lists and data structures are one of the very important thing that you should have a good command on. They are basically they build the your base, right? These are the bases. Okay, now do one thing, guys. Okay, any doubt here, guys? Any issue, any concern you have? So it's quite a modular kind of a structure which can be broken down into simpler pieces because of the indexing. So I want you to take out double L from this structure. Right? So you have to perform slice. So guys, print on only double L. How are you going to do that? So you have to slice this string. So you have to slice out double L from hello. Yes. So you're hearing it, right? Just Deepak, that will work. So basically, if I want to slice out, see first before slicing out, right? First you have to reach to that till that point, right? See, I have to get out LL from hello, so I have to get till hello, and using L2 2 basically L2 double two, you are fetching this. So that is going to work like that only. Right? Yes, Sanmesh. Uh, so this is going to give you basically hello. After that, you have to slice it, right? Now your slicing remains same, right? That we have done in string, or we do it in a list, it remains same. Okay, you simply have to include. See, check the number of element, or what number is L. First element, second element, third element. So first L is third element, that will have index 2. So write it down here. Then you have fourth element, fifth element. You have to go till fifth element, which has index 4. So that is going to give you double L. Right? So that is how you perform indexing and slicing in multi-dimensional lists. Okay, easy, guys. So it does not matter how deep or how much is the dimensionality of the list. You can do the indexing. It could be, see, it is only you have one sub list. You can have multiple sublists inside multiple sublists, and still you can do indexing and slicing in that. Okay, lists are very much comfortable with all these things. Now, one of the very important property which makes lists quite powerful is that your list is mutable. That means that you can change the elements of the list. Okay, mutability makes your list quite powerful. Okay, so this is your L1 list. Right. So I'm coming back to the previous list. Okay. So when I say mutable, see, how do you fetch the elements of a list with the help of index? Okay. Or you can let me repeat the formula for slicing, guys. Okay. Let me write it here. So this formula for slicing is quite simple, right? I'll tell you from the perspective of list. So you have list, right, where you have element one, element two, element three, and so on till element n. Like this. Now, for slicing, if you want to slice, say, EL2 and EL3, right, how do you work? You basically start, or you take the first element, or the first element that you want to take out. You give the index of that element, right? See, we want to take EL2 and EL3, right? That is element 1 and element 2 and element 3. So what you're going to do is you are going to start from the index of this, the first element that you want to slice out, and you will go just, okay, you want to take EL3 also, so you'll go till EL4. Okay, so you're going to go till EL4, right? So slicing will be done like this. L, index of first element to be included, right? Colon, uh, okay, and index of last element to be included plus 1. Okay, you just have to give value one more than what you want. Okay, index, I'm talking about the index, guys. Okay, so this is more, you can say that you can also represent it like this. So it does not matter what element you want to include, you simply give the index of the starting element that you want to include, that has to be there, and then the last element that you want to include, just give an index plus 1 of that, right? So you want to include third element, so you give index of fourth element, right? That is, in a way, you are getting the upper limit, right? This is how you're basically in integration also your upper limits work, right? uh, Not exactly but yeah, you can compare it with that. Position Kuntal, element's position is first, second, third. Okay, how do you find out the index? Right. For nth element, index will be n minus 1. Right. So if your element is third, its index will be 2. If your element is fifth, its index will be 4. That is 5 minus 1 or 3 minus 1. That is n minus 1. Okay. Always remember this. Okay, guys. Now let's talk about the mutability. So whenever you want to fetch an element, see how do you print an element? How do you get the value of an element from a list? You simply call the index and you get the value. Right. So in the list, the element's value can be changed. Like for example, I want to change the value of 1, which is at index 0, to something else. How to make it as this? I can do that. Right. List supports the element change or element assignment, right? You can change the values of the elements inside a list. That is what we call mutability. Like string never allowed to do us so, right? Strings are immutable, but lists are mutable, and that is what makes your list quite flexible and powerful. Right? So lists are highly flexible data structures. Okay, that is what we call mutability. Kindly check and let me know if you have any queries here. Yes, Dave. Stack or queue are implemented using lists only. So guys, understand this: list is quite different than array, right? Okay, there are a lot of other confusion that a lot of people have is that okay, arrays and lists are same. No, array, ARRAY, is a collection of similar kinds of data types, right? That is what we call array normally. So when we define an array, when we create an array, then we keep the data type as same, right? Whereas list is a collection of different, or could be a collection of different kinds of data types. It does not have to be same. Okay, so that is one of the difference, that lists are not array, right, at all. Apart from that, you can add the values to the list. We'll see that. Right? You can queue up the values in the list. For queuing up, you'll have to use the loops. Right? But yes, you can do all these things, stacking up the data or queuing up the data. Okay, next thing is that list supports membership operation. Membership operator is your in, right? If you remember this, in is your membership operator. What do you call it? Is say Vidhan in L1? No, Vidhan is not in L1. Obviously, there's nothing like that. Is say high in L1? Yes. Is high in L1? Nope. Right. So again, you can do this membership operator. You can find out if certain element is inside the list or not. Right. You can have a not in also. Is Vidhan not in L1? True. Vidhan is not in L1. Okay. Check this out, guys. And you can also delete the elements of the list, guys. Right. I can delete a particular, see, you cannot delete or you cannot perform deletion operation on a string. Right. Since lists are mutable, you can add a new number. Right. You can exchange the value. You can add a new value or new element to the list. Right. We'll see that adding the new element to the list. Right. That is basically method when we talk about methods and function after this. You can basically delete a particular element. So I can delete, say, L1. I don't want this huge number. That's in index 0th. I can delete that. Right, so I was able to delete that element. Say I want to delete high, for example. High has got index -1. I can have delete -1. So I can basically do anything that I want on a list, and that is what makes it quite useful. So a list is the only data structure or only structure in Python on which you can do whatever you want. Try it out. Do we consider complexity as a parameter while writing Python code? Because it seems there's not much control in complexity while writing program in Python. Yes, we consider complexities when you're writing the code in Python. First of all, the Python is created in such a way that there is not much of a room of complexity. Right now, there are certain tasks which cannot be achieved by your basic Python. Now, that is one of the very big, you can say that a flaw in Python that I consider. But for that, you have libraries, right? You have NumPy, you have SciPy, you have Pandas, right? Okay, or you have map or graph libraries, right? Images libraries, right? So when you are doing that, when you are working on those, say for example, you're talking about threading, right? When you're talking about handling concurrency issues, right? That time your complexities handling becomes very much important, and especially say for the example when you're working on a server, right? And your server say has a million hits every second, just for the sake of example. No, Dave, once you have deleted you cannot get it back. Okay, so take an example, Dave. If you have a server and that server is built on using Python, Flask or Django, right? Okay, the website, okay, web application. Now uh, some data is coming in, right? Every time new user comes in, right? Right, every second there are 1 million hits. That means that every second you have to handle 10 lakh or 1 million users at a particular time, right? At that time you cannot rely on, say for example, garbage collection to be done automatically, because a lot of data is getting generated, sessions are getting created. So in that case, you'll have to handle the garbage collection by yourself, right? You have to call the library and you'll have to decide when you want to clear the cache, when you want to clear the information, so that your website is remains light and your website is able to handle such things. In that scenario, you have, right, your complexity starts creeping in, right? Okay, and yes, you have the ways in which you can handle those complexities. Python provides you those. Right, you can go deeper into the you can basically manipulate these inbuilt modules, you can say that. Like GC is for garbage collection, SYE is for system, OS for operating system, right? Time or daytime modules. There are so many modules that are inbuilt which you can basically manipulate to handle the complexities. Yes, the inbuilt libraries are actually very much optimized and very much hides a lot of complexities which is going behind the scene, right? But when you want a total control, when you are doing a task that requires you to fiddle with those libraries, then you are exposed to the complexities. Otherwise, Python looks very simple from outside, right? Okay, but again, the simpler the things looks, right, the more complexity is behind the scene, right? Let's take an example of your mobile phone, right? Extraction layer is quite good in Python, right? Everything is, all the complexities are hidden behind the libraries. Yes, oops and design concepts are actually huge. Design patterns are amazing also. Okay. Next thing, guys, that you can do. See, you have deleted this, right? You cannot retrieve whatever you have deleted. You have to leave it like that only. Now, there are certain functions and methods associated with Python which are quite good. Right? You understand methods which are only specific to lists, and you understand functions which are common, which are universal. Right? So the function which are universal is, for example, len. Len can be applied. We applied this on your string also. It can be applied here also. Right. Okay. Apart from that, any other function that you can think of? Print is one of the functions that can be applied. Right. Okay. Let's do one thing. Let's create a list of a number. Right. I have L1, uh, 1, 2, 3. Okay. I'm creating just creating random numbers. Okay. I don't know what value it has and how much is it. Okay. So that is list L1. So I can simply find max. I can find min of L1. So what is the max value in L1 and what is the min value in L1? So these are the two more functions that you have. Right. So when you talk about functions, you have len, which is used a lot. You have max. You have min. So you'll find these functions a lot being used in Python. Functions, you have methods. Okay, now try it out, guys. Max and min. So they are quite useful, right? Max and min for completing small, simple tasks. Now, functions exist, or function is universal. It can be applied anywhere. Methods are only specific to a particular class. So your list is also a class. Like your all the data types, okay, integer, float, boolean, complex, string, which were the classes, list is also a class. So when you're creating L1, you're basically creating an object of class list. So the class also has what? Methods or functionalities which can be controlled. Similarly, this list class also has certain methods which can be used. Okay. Now, if you want to find out the functions, if you want to find out the methods, Methods is always called by the object. Right? L1 is the object dot. You use the dot operator. And guys, if you want to get the hint of how many methods are there with list, simply press tab. Now these are the methods which are associated with list. They are a lot actually. Okay, so I'm not going to work with L1, right? I'm going to work not with L2. Okay, I don't have L3. So let me create another list to make you understand how it works. Okay, so L3 dot, I'm hitting the tab now, I'm pressing the tab. First is append. Now append is a function through which you can actually add a, a value at the end of the list. Right, so that basically shows you the property of a list as a stack. Right, you can append the values at the end of the list. Okay, now L3 dot reverse is for reversing the complete list. Now this reverse, guys, is going to permanently reverse your list. Okay, so that the slicing option of reversing was temporary effect, but this L3 dot reverse function method is a permanent reverse. Okay, so L3 dot reverse. So this is another way of reversing, guys. Okay, apart from that, you have L3 dot clear. Now clear is going to clear your complete list. You will get the empty list. Okay, you don't want that. Oh, you might want that when you have a lot of data coming in and you want to keep your list empty. Then in that case, you can have it like this. Okay, so you can try all these append, clear. Let's go one by one. Copy. Basically, you can copy the list. Right. Now, guys, basically, you want to copy, you want to keep a copy of a list. You call this method. Okay. Then you have count. What are you going to count? How many times one is occurring? How many times 22 is occurring? You can count the number of the occurrence or frequency of a particular element. Frequency of the occurrence of a particular element. Okay. Sure. I'll give you an assignment at the end of the. So you have L3 dot count. After that, you have L3 dot extend. Now, what is extend going to do? Okay. Tell me, guys, what could extend do here? Yes, exactly. You can add a number of elements to the list. Like append adds only one element, whereas extend adds uh, a number of elements. Okay. Okay. So you can have a list. Say we already had L1, right? So what I can do is I can do L3 dot extend. I can extend L1 to it. Then the new L3 that I'm getting is my older L3 plus the extended one which I've included. So using append, you can only add one element. Using extend, you can add a complete list to it. Hey, it's like concatenation. But here you can define how much you want to concatenate. Okay, so you have extend. So I have L3. Okay, I'm going to create a new one. So you have L dot index. So you can find out the index of a particular element. So index of 2 is 1, right? So if you have you have a list where you have elements, same elements, and if you find out the index of say 1, it's going to give you the index of the first occurrence or element which is occurring first. Right? So that is a kind of a limitation of this index. Okay, guys, so this is how you do indexing. Then you have insert. Okay, what insert is going to do, guys? Anyone? Try it out. Insert takes two values, right? One is the index, other one what you want at that index. Right. So you have append. Okay, append is going to add the value at the end of the list. Then you have extend, which through extend you can add a whole lot of elements, bunch of element at the end of the list. Then you have insert, where you define where you want to insert an element. So I've defined that, okay, I want to insert an element on 0th index, and what element I want to index? This element. Okay, so at 0th position, 234 was included. See, the time that we are spending on this is not, we won't be able to spend that much time on tuple because tuple does not have that many methods. Okay, similarly, your set also does not have this many methods. Similarly, your dictionary also does not have this many methods. So if you understand this properly, then tuple, set, and dictionary becomes easier to understand. Okay, so you have insert. So you can insert at any index you want. The first argument that you'll have to pass is going to be the index. Finding duplicates in a list along with its index. I'll have to check if we have method for this. Otherwise, we'll have to do it by the old way, right, using the loops or the control statements. Let's see, might have this method. Might, I'm not sure. L1 dot. No, we don't have this method, Dave. So these are the methods that you have in with lists. See, all these are all the methods that you have with lists. Okay. Then you have pop. Pop is for removing one of the element. Normally, it removes a random element. So it is popping the random elements. It does not have to be the, see, it seems last element, but normally it does not have to be the last element, right? So if you try it out on a different IDE, if you try it out on an IDLE, it might behave differently. Okay, try it out. Basically, you can also give the index to the pop. Say, for example, I want to pop, say, index 0. I can do that, right? So you can also give the index to the pop. Yes, it will show or pop the last element, but many times it also pops the random elements. Now, you don't want to remove an element with the help of index, but you want to remove the element by the name of the element. So you list this like this. Say, for example, I want to remove an element whose name is 33. So I have to give the name of the element. So pop, with the help of pop, you can remove the element if you know the index. With the help of remove, you remove the element with the name of the element only. Yeah, try it out. Remove and see copy. Okay. Let me show you count. Okay, before showing count, let me create a list which has multiple counts. Okay, so this is your list. If I do L2 dot count and count one, how many times one is occurring? You see that one is occurring once, twice, thrice, four times, five times. So you're able to count the frequency of occurrence of a particular element. Okay. Then you have a method to actually copy a list, which is the copy method. See, now your copy might seems a bit different. Like that, okay, is it same as writing L1 equals to L2? Right? If I write, okay, let's say I have L3 equals to L2 dot copy, or L1 equals to L2. So if you have L3, if you have L1, then they both are same, right? Okay. So you might say that, okay, why I'm using copy method? Why not I'm simply writing L1 equals to L2? So the actual reason is that when you write L1 equals to L2, you're changing the reference only, right? You have created another reference. Now this reference object is pointing toward the location where this data is stored, right, of L2. Whereas when you do L2 dot copy, you are basically creating a new space where a new data is stored, right? So this is creating a new space in the memory. It's just not reference, it's completely different memory space. Okay, that is what your copy does. So copy does not copy the references, it basically copies and creates a new space for the elements, for the list. Okay. Good, guys? Copy, which one you have? L1 dot sort. So you have L1 dot sort. Now, what is L1 dot sort is doing, guys? You can see the difference. So basically, it is sorting it in a ascending order, right? So you have 1 1 1 1 2 2 2 23 3 3 3 34. So it sorted it in the ascending order. Now you have 1 1 1 2 2 2 3 3 23 and 34, right? So that is what your sort does. In Python lists, it sorts in ascending order. Count does not work on multi-dimensional lists. Okay, let me check. I think it does. Oh yes, first see the sorting, then I'll tell you. No, 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 Sagar, it's not going to work like that. So when you are doing count, you give the immediate element. You don't refer to the element which is inside another list. No, it's going to be considering the elements which are there, right? Not inside the list or inside the list of lists. Okay, let me copy this. Right, this is your list. I can only count the immediate elements that you have, and all the elements are lists. So if I want to count the occurrence of one, I cannot find it directly. Okay, it's going to give me an error. So that is not an element. Or basically, there is no occurrence of one. Right? So it's giving me zero. Right? Basically, it's not giving you the error. Okay. You can do it like this. Okay, so you want to count the occurrence of one and the first element of the list, which is again a list. So you refer to that list, then you do the count one, and you have one occurrence. Okay. Now there's another concept which is called unpacking of the list, which is quite interesting and quite important. Okay. So basically, unpacking of a list is also used a lot. It's quite important. Okay, so you have a list like this. Let's call it li, because to
1, comma 2, comma 3. So what I can do is I can basically unpack it. How? A comma B comma C equals to Li. A, B, ABC, right? So each variable that I'm creating is basically assigned the each element of the list, right? That is what we call unpacking of a list. It's a simple formula and it has a lot of very good usage actually. Good guys. So that completes your list. So that is all you have in the list. This sort of thing will involve a lot of looping through it, right? Or list comprehension, right? That is again very important. We're going to see that in the future, but that completes the basic of the list. Okay. 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 So we have sorted lists in an ascending order. Now, how can we sort lists in descending order, guys? Okay. Let me show you. So it's very simple, right? L1 dot sort. You can have RAVRS. See this to sort the list in a reversing or reverse order. Okay. Yes, sir. See, the right approach, see, these are just to make your life easier, right? The right approach would have been using a loop, right, for sorting it. But again, in the background only, it is looping through it. No, reverse is going to reverse the complete list. Yes, you can do that also. That is again a right way actually. Okay, what you're doing, Dave, is actually correct. Right, you can do it like this. You have L2 equals to say some list like this. You can do L2 dot sort. You have L2. You can do L2 dot reverse. Okay, it's going to sort it in a reverse order. So that is what we have done, but with a parameter. That's it. Yes, it's a permanent. Yes, it's permanent. Yes. Okay, I didn't understand the two section at the top of it. What are you trying to say? What are you trying to say? Yes, there are two calls, sort and reverse. In that, in a single sort with its parameter reverse equals to true, we are simply doing it in a one shot. But behind the scene, it is working in the same way. Okay, so that is your list. So we have completed list, unpacking of list. Now next is what we called tuple. Now tuple is what we call read-only list. So that solves a lot of understanding, right? A list which cannot be manipulated is what we call tuple. A list that cannot be manipulated is what we call tuple. Now, how do you represent this? You use parenthesis instead of square bracket of list. You use parenthesis here. You have element 1, you have element 2, you have element 3, and so on. Okay, and elements are your data types. Okay, so you have t equals to parenthesis open and close 1.1 true. Right, so you have tuple. Right, try it out. So you can do all those things. Yes, Swati, tuple C. It's a read-only list. That means that it's not, it cannot be edited. So these are immutable. Yes. So you can do all those things that we did with the list. You can do all those things with the tuple also. It supports concatenation. See this, guys. Concatenation is something that it supports. Repetition it supports. Indexing, reverse indexing it supports. Slicing it supports. Multi-dimensional list or multi-dimensional tuple it supports. Okay. Now mutable is something which it does not. It is immutable. Membership operator it supports. Function remains same. Methods will be different. Unpacking also remains the same. Right. So you can try all these things, guys. Okay, try it out. Try start with concatenation. Have another tuple. T plus T1. Uh, any function to get the size of a tuple on a memory space, right? You'll have to use the library. See, first of all, okay, okay. Let me show you one thing. Let's say that you have tuple. Let's call it T2. T2 is your 1, 2, 3. T2 dot. I can use attributes here. Mhm. Okay. Okay. Something that I want to show you guys. You have T2, right? And I did T2 dot size of. It's gave me size of tuple. Similarly, you can have list. Say that L2 and L2 is of the same size, or L2 has the same element. They'll see that list takes more space than your tuple. Right? Okay, Dave, you can find out the size like this. So your basically lists are your variable size and tuples are of your fixed size. Uh, the reason is, see, simple reason is because you can add, see, lists are of variable size, right? Your tuple, once you have created, its size is going to be same. Your tuple 1, 2, 3 is going to be same no matter what. You cannot manipulate this tuple, so it's of a fixed size. Whereas your lists are kept as an elastic structure where you can add and you can delete the objects, right? So it is by default kept as of bigger size, right? Because now you can manipulate a lot of things here, like L2 dot append. Let's append this. Your L2 became this, right? You can see that the size increased. Okay. So since it is mutable, its size is kept initially as larger one only. Okay. Yes. Initial storage size is more by default. Yes, you can see the size of object. You can see the uh, memory space that is it refers to by default is of larger size allocated to list. It's so basically, guys, when you want to store data, when you have a huge data, when you want to store the data, then you prefer storing data in format of tuple because it takes lesser size. Then if you want to manipulate the data, you convert that data into a list, you perform manipulation, and again then you convert it back into a tuple and you store it. Right. So for memory management, your tuple plays a very big role. Right. Okay. Now let's see all the functions that we can use, all the things that we can do with the tuple. So you have L1, or let's say L2. Yeah, L2 is good. Sorry, we are talking about tuple. You have T1. You can do T1 as repetition. You can have T1 plus T2, that is concatenation. Okay, apart from that, it supports slicing. Sorry, indexing. It supports slicing. Now, slicing and indexing is something that I want you to try by yourself, right, guys? So try these two, indexing and slicing, reverse indexing and slicing. It's easy. Yes, I'm coming to that, Sagar. Way to convert list into a tuple and tuple into a list. It's quite easy actually. Right, that will come under your functions and methods. Okay, we have not reached till that point, right? Functions and methods are here. Yes, so I'm assuming that you will be performing indexing, reverse indexing, and slicing. Okay. Next thing that you have to do is multidimensional tuple. So you can have T3 equals to, tell me, can I have it like this? Yes, you can have multi-dimensional tuple. And the same thing that we did in with multi-dimensional lists, the slicing and the indexing, the same approach is applied here. Right? You can use the same approach. Sure, Dave. What is the query you have? Yes, Dave. Today's session also ends at 10. Uh, Yesterday and today we have some maintenance activity. That is why I'm not giving any break, right? Okay, so that we can have a straight 2 hours session instead of a break in between. I hope it's okay, guys, that we don't have a break in this 2 hour session. If you wanted, we can have a break of for 5 minutes, guys. But will it make sense at 9:35 having a break of 5 minutes? Let me know, guys, if you want a break. We can have a break of 5 minutes, or we can continue till for 25 minutes till 10. Okay, so that is your tuple. After that, It supports, see, tuples are immutable. That is something that you can write. Okay, I'm going to copy this, guys. Tuples are immutable. That means that you cannot change the data inside it. So zeroth index, I want to change from 1 to triple one. I cannot do that. See, tuple object does not support item assignment. That means that they are immutable. You cannot do it, right? You cannot do such things. You cannot delete a particular element also from here. It does not support item deletion. So you cannot actually manipulate anything which is inside the parenthesis. Right? You cannot do that. Yes, tuple uses parenthesis or circular brackets. Yes, exactly. Tuple uses this. List uses square brackets. Yes, the application of tuple and list, I'll explain that too. List is basically for manipulating anything and everything. You use list, right? And if you don't want your data to be manipulated, you don't want your data to be manipulated by anything, you want it to be write protected, then you store it as tuple, right? So your data will be write protected. That is one thing that you use. Apart from that, it's easy for, or it's fast. See, when you go through the list, it's slow, right? Your Python goes slowly through the list, but your Python goes very fast through the tuple. Okay. Now, this has something to do with the concept of namespace, right? So I'll explain you that namespace concept when we'll talk about namespace. But understand this: iterating or going through the tuple is way faster than going through the list. Apart from that, when you store the same data in form of tuple, it occupies lesser space than the data that you have stored, the same data that you have stored in the format of list. Right? That is another very important thing about list and tuple. Okay. Now I cannot delete a single element from a tuple, but what I can do is I can delete a complete tuple itself. Right? I deleted complete tuple. So again, you can delete the entire tuple, but you cannot delete or edit or add anything inside the tuple. That makes it quite interesting actually. For looping, if you want to loop through a data structure which and you want to loop through fast, then you loop through tuple instead of list. Yes, values are constant in case of tuple, and pointer, yes. Reference can be changed always. It supports membership operator, guys. Uh, Is Vihan and T2? Nope. Right, so it supports membership operator also. Now let's check the functions that is supported by your tuple. Try it out, guys. Try these functions out. Functions work on this. Try it out. So you have T2. Does length, len is basically your length, work on this? Yes. Does max work on this? Yes. Does print work on this? Yes. Does min work on this? Of course, if max is working, min is going to work. Right. So these are the you can see that functions that work on this. Now, since guys, there are not many things that you can do with tuple, so the methods are also limited. So if you type t2.tab, you'll see that there are only two methods. One is count, other one is index. That's it. You can count the occurrence of any element, or you can count, or you can find out the index of a particular element. There are only two methods associated with your tuple. That's it. Okay, try it out. These two methods have something that we have used already. Now, apart from that, it also supports unpacking. Right, you have a comma b comma c equals to t2, unpacking of tuple. Okay, it supports unpacking also. Index method, okay. Let me tell you. So basically T2 uh, or any tuple object dot index, you can find out the index of the element. You simply give the name of the element. So element, okay, let me have T1 equals to something different, right? Let's have string. Okay, that is your T1. You can find T1 dot index. I want to find out index of high. So index of high is 1. Okay. So basically you can find out any index with the help of this method. Okay, got it guys? So these are the methods associated with index. Now there are two more functions which are quite useful when it comes to list and tuple. That is interconversion of them into one another. Say you have tuple T1, right? So I can convert this tuple into a list. Simply have to call the function list and have to pass this tuple. Right? So it got converted into a list. So list is a function, right, where you pass the tuple and it will convert tuple into a list. Similarly, you can do for tuple or list, you can pass the list through a function called tuple, and it's going to convert the list into a tuple. Yes, Ramesh, you can also do that. Actually, that's a good option. Okay, so Ramesh is saying that what we can do is I can have right. So I can find out the index of the internal elements also. Yes, reverse is also true. Okay. Now let's see what tasks you can do with this. Uh, so you have a list. Okay, you have a list which has a tuple as an element also. Okay. So what you need to do, guys, so this is a task that you have to perform as a homework, right? You need to convert this list into a tuple, right? And you have to convert the vice versa, this list into a tuple, and the inside elements which are lists into the tuple. So this will become a tuple, this tuple will become a list, and so on. So whatever is list has to be turned into tuple and vice versa. That is something that you have to do. Okay, take it as homework. Apart from that, say you have a tuple which contains a tuple and list and tuple and list. Okay. Okay, so you have this tuple. Now on this tuple, you have to try to, or not try, change the elements of the list inside tup. Okay, that is a task that I have to do. Okay, so take these two tasks, try it out. Right, I'll give you more tasks next week. Okay, so you'll learn a lot of things regarding tuple and list with this two task. Okay, any queries, guys? So guys, this is all for today. If you want to sign off, you can sign off. If you have any queries, you can ask me. So we have completed lists and tuples. Next week we are going to work with set dictionary, and we are going to move to control structures. That is if, else if. Then we are going to move to loops. Right. So that is what we are going to cover next week. Control structures and loops, and we are going to move to list comprehensions. Then we are going to move to functions, modules, and regular expression. After that, we are going to perform a lot of practicals, real-time problem solving, like a lot of use cases we are going to cover. Right, like reading the log file, reading Excel sheet, how to automate the task, how to do a lot of different tasks. Okay. You want everything on the notepad? So I'm going to share a basement because the chat box has a characters limitations. So I don't think that is going to be will come in a single chat box. So I'm going to create a basement link, guys. Okay, so you have the notepad files. You cannot access the LMS. They've kindly contact the support team. I have no nothing to do with the LMS. Right, I have no access. Even I don't have any access, I suppose. So yeah, we have that in common. But to be on a serious note, kindly contact support team. Right, they will be able to help you out in this. Right. Any queries you have, guys? You can ask me. Okay, then, guys, that will be all for today, and we'll continue from here next week. Sure. Welcome, guys. Have a good day. Have a good week. Bye bye. Signing off now.